In this video, we'll focus on the second half of section 12.4, which focuses on ways to express concentration of solutions. In the prior video, we talked about percent concentration. In this video, we're going to talk about molarity. Molarity is very common because it goes to the base unit of moles. So the molarity of a solution is simply the ratio of the moles of the solute per liters of solution. So molarity, represented by capital M, equals the moles over the liters. Moles of solute, liters of solution. It's not a percent, there's no times 100. And we must have moles for the solute and we must have liters for the solution. We're going to see in our sample calculations if we have grams of a solute, which is very common because you measure out your powders and your crystals in grams on the balance. Those amounts will need to be converted into moles. Liters is a unit that in the lab you're more likely not to use. You're more likely to use milliliters. So conversions from milliliters to liters is very common, but we need to have moles of solute per liters of solution. It's referred to molar concentration. In the chemistry lab, we have a lot, and in the lab manual and in the labs that you had done in person, you've already have used solutions that are labeled with molar concentrations. 1.0 molar hydrochloric acid, 3 molar nitric acid. So that's how you would refer to these. If you would say, could you hand me the bottle of the 1 molar hydrochloric acid? We don't say 1 molarity, we say 1 molar. So we're going to do calculations where we calculate the concentration, the molar concentration. We're going to do calculations where we calculate the amount of solute needed to make a certain molar concentration solution. And we'll do calculation where we calculate the amount of solution given the amount of solute and the desired molarity. Let's do a calculation. What is the molarity of a solution made by dissolving 2.00 grams of potassium chloride in 150 milliliters of solution? So potassium chloride is a salt, okay? It's a crystalline substance. So 2 grams of it are measured out on the balance. We want to make a 150 milliliter solution. We assume it's aqueous. What is the molarity of that? That's what we want to find. Well, molarity is equal to the moles of the solute over the liters of solution. Do we have moles of solute? No, we have grams. Do we have liters of solution? No, we have milliliters. So we need to get these into the appropriate units. First, what's easiest to do is to convert the milliliters to liters. 150 milliliters is equal to 0.150 liters. Okay, that would be the liters of solution. Now we need to convert the grams to moles. We use molar mass from chapter 7 to convert from grams to moles. So now we want to convert grams to moles using molar mass. So we have 2 grams of potassium chloride that we want to convert into the equivalent moles of potassium chloride. So we have the molar mass potassium chloride, 1 potassium, 1 chloride. Okay, so we add those atomic masses together, 39.10 plus 35.45, look directly at the periodic table. Molar mass of this substance is 74.55 grams. Okay, so now we have our conversion. We can convert this amount of solute in grams into the amount in moles. Cancel out grams. 2.00 divided by 74.55 gives us 0.0268 moles of potassium chloride. Okay, well now we have what we need to find the molarity, to find the molar concentration of this potassium chloride solution. So the third step would be to find the molarity, moles over liters. Okay, well we have 0.0268 moles over 0.150 liters. You do that calculation. You get a molar concentration of 0.179 molar potassium chloride. That's your final answer right here. Okay, so this was the formula we need to use, our first step, our second step, and our third step. Okay, so that's how we would calculate the molar concentration of a solution, or the molarity of a solution. Okay, let's do another problem where, let's say we have the molar concentration. Let's say we have the molarity, the molar concentration. And let's say that we know the amount of solution that we want to make. Okay, so let's say that there's a solution needs to be made for a certain reaction. We need it to be at a certain concentration, and we need a certain amount of it, a certain volume of it. Well, how much of the solute should we measure out in order to make that specified concentration? Let's do an example like that. All right, let's say we have that potassium chloride. We have that ionic salt. And let's say that a 2.50 molar potassium chloride solution is needed for some reaction. If 600 milliliters of solution are required for use, how many grams of potassium chloride are needed to make this solution? Okay, so potassium chloride, it's a solid. It's a crystalline solid. We know that we need a solution for a total volume of 600 milliliters. Okay, we need 600 milliliters of this solution, and we need it at that specified concentration, 600 milliliters. Okay, I don't have a volumetric flask with me, but we need this much. Okay, so how much of that potassium chloride do we need to measure out? Okay, let's look at the information that we have. We have the molarity. We have the amount of solution. So now what we are going to do is calculate the amount of solute. Initially, we'll get the amount of solute in moles. We'll get the moles of potassium chloride using the concentration and using the milliliters of solution converted to liters. We will find the moles of the solute, and then we will use the molar mass to go from the moles of potassium chloride into the grams of potassium chloride. So first we need to get this milliliters into liters, okay? So we want to get, that's the easiest step to do first with these calculations. Okay, so 600 milliliters. And yeah, I know you can just move the decimal, so if you feel confident in just doing that step in your head, by all means go ahead, but I'm just going to show it for the sake of explanation. Okay, milliliters cancel out. I'm keeping the three significant figures. Okay, second step now, we would use M equals moles over liters, and we're going to find the moles of solute. Okay, so we have the molarity, we have the 2.50 concentration, molar concentration. The moles of potassium chloride, we don't know that, but we have the amount of solution. Okay. So we would multiply these two amounts together. Let me show that up here. Okay, so remember that the M stands for the moles over the liters. So if we look at it in this way, we see that liters would cancel out and we would be left with the moles of the potassium chloride. That would give us a product of 1.50 moles of potassium chloride. But you're making a solution. You don't have a balance that has units of moles. You have a balance with units of grams. So now you need to convert the moles into grams using molar mass, so you can take that balance with the weigh boat, okay, tear out the weigh boat, and you can measure out the amount of potassium chloride you need to make 600 milliliters of this solution with that concentration. So our last step in the calculation would be to convert the moles to grams using molar mass. So that molar mass that we learned in chapter 7, it doesn't go away. It's used a lot. So 1.50 moles of potassium chloride. The molar mass of potassium chloride we did in the example 1. So it's 74.55 grams per 1 mole potassium chloride. The moles cancel out. So we have 1.5 times 1.50 times 74.55. You do that and you get 112 with, if you follow significant figures, grams of potassium chloride. Okay, so you would measure out this amount of potassium chloride. Okay. So say you're actually physically making this solution. Okay, you would use a volumetric flask. I do not have one on me right now because I'm not in the lab. But you would take 112 grams of potassium chloride. You would measure it out on the balance. And then you would put it into a volumetric flask. And then you would add a Teflon coated stir bar. And then you would add distilled deionized water up to the 600 milliliter marking on the volumetric flask. And then you would, assuming, I'm not sure if they make a 600 milliliter volumetric flask, but they probably do, but not as common. But anyway, you would fill up to that line, and then you would put the solution on a stir plate. In the stir bar, it would mix the potassium chloride salt around, mix it with the water very thoroughly, so that, and then you put a label on it, 2.50 molar potassium chloride solution, and you would have the solution needed for whatever reaction you were doing. Okay, last possibility, let's solve for the amount of solution. Say you know the molarity, say you know the amount of solute, but you need to know a solution volume. Let's do that type of calculation next. Okay, let's look at finding the amount of solution. Let's look at this scenario. How many milliliters of a 1.75 molar potassium chloride solution can be made using 0.895 moles of potassium chloride? So let's say you have the amount in moles of the potassium chloride crystalline solid, and you know that you need a concentration of 1.75 molar solution, but you want to know how much solution will that make. Okay, this is what you have left in the bottle. Let's say you have so much material left in the inventory, and you need to make this concentration. So what amount of solution can you make with this? Okay, and the molarity section is very real in laboratory situations. You need to have molar concentrations because it bases the solution amounts on the base unit of the mole. Okay, so these kind of calculations are very realistic in many lab settings. So, all right, let's find the amount of solution. Well, we know that we have the molarity equal to the moles over the liters. Okay, moles solute, liters of solution. Well, we have the molarity and we have the moles of solute. So essentially we're solving for this quantity in the denominator. Okay, so we have 1.75 molar. The moles of solute we have, but we don't have the amount of solution. Okay, so our first step would be right here, solve for liters of solution. Okay, that's our first step that we're going to do. Okay, essentially in conclusion we want it in milliliters, but first we will find it in liters. Okay, so you have to do the math. Okay, and again, however you like to do the math, whether you like reciprocals, whether you like cross multiply. I like to show the cross multiply way because I'm old and that's how I learned it. It's math, it works either way, okay? There's only one right answer, whether you use old math or new math. There's only one right answer. Okay? Remember that molarity is the same as moles over liters. Okay? So now we want to solve for liters of solution. If we divide both sides by this here, 1.75, okay, cancel that out on the left hand side. On the right hand side, units of moles cancel out, and now we're left with liters of solution equals 0.895 over 1.75. Okay. So you have 0.510 liters of solution. I'm just keeping everything with three significant figures. Okay? So that will give us liters of solution. However, we are asked to find the final answer in milliliters. So the very last step would be to convert the liters into the equivalent milliliters. So second would be convert liters to milliliters. Okay, so trying to keep this neat. Okay. (510 milliliters). So that's the amount of solution that you could make with 0.895 moles of potassium chloride to get a concentration of 1.75 molar potassium chloride. Okay. For those of you that are going on to take Chem 121, this is a topic that comes up a lot sooner in Chem 121 and is used in more calculations than what we do in 110. So you want to make sure that you get a good understanding of molarity, especially if you're continuing on to Chem 121 and Chem 122. In the next video, we're going to do dilutions of solutions, and that calculation is pretty straightforward. Okay.